Welcome to our new video. So today we are going to solve the new question. Count number of nice arrays. Nice subarrays. Given an array of integer nums and an integer k, a continuous subarray is called a nice if there are k odd numbers on it. Return the number of nice subarrays. So what is the question saying? Suppose this is an array nums. We have to find the number of nice subarrays. What is nice? It should have k odd numbers in it. So k is 3 here, so the subarray should have 3 odd numbers in it. For example, here if we would take this subarray, it has 3 odd numbers, which is 1 1 1, and if we take this subarray, this also have 3 odd numbers, which is 1 1 1, and even number is we do not have to take. So similarly in this it has no odd number, so 0 subarray, and in this there are 16 subarrays. There will be 16 subarrays like this, and similarly this. Many are there which have 2 odd numbers in it. Okay, so let's try to solve this question. Let's take an example. Suppose this is an odd number. We should have k equals to, we were taking this example, equals to 3. So let's try to find brute force. What's the brute force? We'll make subarrays using 2 for loops, and when we found that odds equals to, we will initialize it with 0. When we are on this index, we have 1, then and we will increase the count of subarrays when we found 3 odd numbers in it. When this we are odd, we are having odd 2. When we are on this, we are having odd 2 only. We are on this, we have odd 3. We are having odd 3s. So count increased to 1. Now when you move here, odd becomes 4, and we break from the while loop. Now again we start from here. 1, 2, 3. 1, 2, 3, and when we are having 3, then we will increase the count to 2. So this is a brute force approach. It will take big of n square and space complexity big of 1. So this we have solved. Here you can see its code. For loop, initialize with the odd with 0, and this is a for loop. We will increase the count if we find odd number. For odd number, we are checking like this: if it is divisible to or not. If it will give remainder, it is odd. And if we got odd equals to k, we will increase the count. And if odd becomes greater than k, then we will break the loop. Why we are? Because then we do not have to move further, because it will be not nice array. So this was the brute force. Now what is the optimal solution? For optimal solution, we will relate it with yesterday's task. Yesterday's question. What was yesterday's question? We were given the goal and a binary array, binary nums array. Suppose like this, and we were given the goal equals to 3. So what is it means? We have to find all the subarrays, count number of subarrays whose sum is 3. So we use the approach. Which approach? We took an approach like we pass nums comma goal minus nums comma goal minus 1. What this function was doing, it tells that at most goal whose sum number of subarrays whose sum is less than equal to goal means at most goal. And this was telling at most goal minus 1. Number of subarrays whose sum is less than equal to goal minus 1. When we were subtracting, it is giving count 1, it is giving count 2. Suppose when we are getting the answer, which was count of subarrays whose sum is equal to goal, because suppose this is less than equal to and this is less than equal to goal minus 1. So what is this left? If we subtract this from this, we're left with this, and this is equal to goal. This was the approach we discussed, and what's the code we have written yesterday for this. We took a sum 0 and a count what we did, left pointer, right pointer, sum is 1, sum is 2, and when sum is 1, we'll increase the count because it is less than equal to goal. When sum is 2, we'll increase the count. What is the count? How many subarrays you are seeing? 1 and 2, 1 and 2. So 2. Also, when r moves here, sum is still 2. We will add 3. Why? We are adding the length actually. We are adding r minus l plus 1. Why? Because suppose you are having 1 1 0. How many subarrays you can form? You can form this. Okay. When r moves here, sum equals to 3 and count increases to 4. When r moves again, it becomes 4. Now we have to update the L pointer to this. When it becomes 3, we again check the count. We again increase the count. Count is 4. Now our pointer moves and value breaks, so we get the count. What is the count? 4 plus 4 8, 8 plus 3 11, 11 plus 2 13, 13 plus 1 14. We get the count 14. Now we will do goal minus 1. Goal minus 1 less than equal to goal minus 1, which is 3 minus 1 equals to 2. So let's take our left and right pointer, a sum, a count, first of all 1, then sum 2 plus 1 plus 2, or sum is still 2, count is 3, sum is 3, and we have to update the left pointer now. Now sum becomes 2, counting is 2 3. Now sum becomes 2, so count increases. Now again we will increase the r, sum equals to 3. Now we will update the L, sum is 3. We will increase the count. Now L again increases, sum reduces to 2. Again it is 2. Then left pointer again increases, then right pointer increases, and the count is 1 plus 2 plus 3 plus 3 plus 3 9 plus 2 11 11 13 14. Wait a minute, something is wrong. I will do again. Wait a minute. Again we will do this dry run. Something is wrong. Now we will do 1 1 0 1 1. Now go. It is less than or equal to 2. Left pointer, right pointer, sum equals to 0, count equals to 0, right pointer increases, sum is 1, count is 1, right pointer increases, sum increases to count, sum increases to 2, and count increases to 2. Then again when right pointer increases, sum is 2, count is 3. Again right pointer increases, sum is 3, we will update the left pointer. Now see the sum is 2, then count increases, then again we will increase the right pointer. When we will increase the right pointer, so count increases to 3, sum also becomes 3, here sum becomes 3. Now we have to increase the left pointer, sum decreases to 2, we will increase the count to with 3. Then when right pointer increases, while loop breaks, and we got the sum 9 plus 2 11 plus 2 12 plus 1 12. So answer, what is answer? It is 14 minus 12 equals to 2. So this was the dry run. Now let's code this. Now let's relate with today's problem. This was yesterday's problem revision. So today we are given in place of 0 we can imagine even numbers. It is similar to yesterday's problem only in place of even and odd. In place of odd we have 1, in place of even we have 0. Let's imagine this is the pattern you have to recognize for the question. Now let's code it like yesterday. So we will make two variables, left and right pointer, 2 pointer, and we will make count, we will make sum. Now while loop r is less than equals to nums dot size now if nums r is divisible by, because we have to check odd, if divisible by 2 equals to gives 1 remainder ones, then we have to increase the count of odd. So odd increases to 1. Similarly, if somehow odd becomes greater than k, then what we have to do? If nums of L is odd, then we have to decrease the odd and increase the left pointer. And what the count will be? Count will be updated to r minus L plus 1. Similarly, r plus plus, and we can return the count. And we can make a function of this code. We have to return f nums k minus f nums k minus 1, and we can make a function int f. We can paste this, and what is the function parameters? We will pass these parameters, and also one condition, one edge case of k less than 0, we will return 0 for this. If k becomes minus 1, k is 0 suppose, then 0 minus 1 will be minus 1, so it is invalid. No count is minus 1, so we have to return 0. If we run this, I hope it should work. Yeah, it works. What is the time complexity of this? Time complexity of this is a type of big of 2n will be here, big of 2n will be here, and big of 2n will be here. So approximately 2n plus 2n similarly. I hope you understand this question. You understood this question. Thank you, and we will meet in the next video.